Okay. Okay. So, does hardness matter? Well, oh god. Okay. You gotta get it out. Okay. Okay. So, does hardness matter? Well, 10 out of 10 people that have sex would agree. But when it comes to analyzing a mystery like the pyramids, I would have to disagree. I would say that hardness does not matter. So, what do I mean by this? What do I mean by hardness? So why does this matter? Why doesn't it matter? Okay, so let's look up what hardness means. So we have the Mohs hardness scale, and this is the scale that everyone talks about when they're talking about Egypt and they're talking about the hardness of materials, and they say that, well, it's impossible that they could have cut the blocks because they didn't have any materials hard enough to cut them. You see, the blocks is so hard, and they didn't have any materials that were harder than the block, so it was impossible for them to cut it, so therefore magic. I can see where people are coming from, and I think it's kind of interesting how this became a big discussion point. So the Mohs scale is a scale from 1 to 10, and it characterizes the scratch resistance of materials. And so when you're doing the Mohs hardness test, they have like a standard instrument here, and then they use that to sort of describe the different materials and see how much force is required to describe them. I'm sure there's probably more subtle details about that, but that's the gist of the Mohs hardness scale. So here's the scale here, and it's kind of it's very intuitive, right? So like we have the talc here being soft, and then we have up here at the top with diamonds being really hard, and these different things on the list. It's not only diamonds can be a 10, or that only fluorite can be a 4. This is just sort of to give you an idea of how hard they mean when they're giving out these different numbers to the hardness scale. And so Right, so here we have a different list where it shows different materials at the different hardness values. And so when people are talking about the building the pyramids, what they'll do is they'll say, well, if we look, the material they're cutting, that's a hardness somewhere up here. It's like a quartz hardness, the granite or whatever. But in order to cut that, you need something stronger than that. And it's like, and they only had access to copper, and so like copper, well, that's not hard enough to cut one of these hard materials. They would have needed something stronger, and okay, so how? Okay, so this list isn't meaningless. Like it, there's clearly like been a lot of work done here, and I'm not arguing that that diamond isn't harder than these other materials, that the list is wrong or anything. But when we're trying to consider whether or not a certain material can cut another material, we have to consider all of the properties of a material. And so if we take, for example, glass, material properties, and if I can find a good source. Material properties. So if we look up glass, and you can find different material properties lists. They seem to be, a lot of them seem to be behind a paywall, but you can see here different examples of different properties people are looking at. So like we have the density, the crush strength, softening temperature, the fracture strength, the compressive strength, the shear modulus, property elastic, brittle, elastoplastic, rupture, elastic, and so these are all different material properties as well as hardness. So hardness is just one material property, and so when you're comparing whether or not two materials are able to cut each other, how can you say that one material can't cut another when you're only looking at one property of that material? Now, with glass specifically, glass is a really interesting material because it is bouncy, but it's not elastic, and it's not plastic, it's crystalline, and it's hard, right? These are all different material properties it has, but the bouncy one is the most interesting because I'm sure most people have experienced this. You have a glass, and you can take it and throw it across the room. It bounces around and lands, and somehow it's all in one piece. And then you like barely nudge the thing and it completely shatters. And this is specifically because of the bouncy material property, where like in the right circumstances, when it's under the right acceleration, when it's hitting against the right materials and stuff, the bounciness is able to absorb that shock and make it so the glass doesn't even break. And so if I was trying to predict what was going to happen when I dropped a glass on the floor and I was only looking at the hardness, I would never be able to know that it would bounce, and I wouldn't know why it bounced when it did, and so this is a very important consideration. So given that like people like know about material properties and material science and whatnot, so why is it that this keeps getting brought up as like this sort of this thing where it's like, see, the hardness, this is the can't think of the colloquialism, but this is the thing that it proves beyond a shadow of a doubt that there could have been no other way to have cut these blocks than magic. And so where does this come from? So when you're working in some kind of shop, machine shop, a wood shop, any kind of shop where you're making stuff, these are dangerous places. So and so you need to have rules and things to govern yourself by to make sure that everyone stays safe and no one gets hurt using these dangerous machines and whatnot. So what happens is we have this Mohs chart, and look how simple it is, right? It's very easy to understand. This material is harder, therefore it's stronger. This material is softer, therefore it's weaker. And so you can use this scale as like it's a very easy way to make a safety rule for your shop. And you can say, whenever you're cutting material, you have to make sure that the cutting tool is always harder than the material that you're cutting. And this way you can stay safe. So like if I'm trying to cut a piece of metal and I'm using a blade that's made out of wood, well, the wood is softer than the metal, so the wood's just going to shatter everywhere and it's going to hurt me. And so it'd be wiser to use a metal blade to cut a piece of wood. And so using this scale, you can have this very easy to understand guide for shop safety and keep people safe, and it works. Because for the most part, you can make these safety predictions based on this scale. And then you have another place where this comes up is when you're making engineering decisions. And so say for example you're building some machine and you have two parts that rub up against each other. This part over here, it is really, really hard and difficult to make, and this part here is really, really easy to make. And so what you do is you take the part that's really, really, really hard to make and you make it out of a harder material than the part that's really easy to make. So then when the easy to make part rubs up against the hard to make part, well, the easy to make part rubs away. And so now you can just replace the easy to make part and continue on. You don't have to worry about trying to recreate this hard to make part. And so for making like very basic, quick, easy engineering decisions, this is a very good scale for doing that, because you can this is the only number you need to look at in terms of material properties. You say, okay, well, this material is softer, so we're just going to make it out of this material. This material is harder, we're going to make it out of that material. And I feel like what's happened here is that we have this thing where the Mohs hardness scale is this big shop safety tool, and and it's this very good engineering decision matrix, and this is being applied to the pyramids, but you're only looking at the hardness, right? The other material properties matter. Okay, so what are some examples of this? So a really good one is, this would be better on this chart. So we have diamonds down here. They're number 10. They're the hardest. And then I think at 4.5, ordinary steel. And there might be other types of steel that's maybe a little bit harder, but the point being that the steel is softer than the diamond. And so if we're only using this Mohs scale and we're trying to predict what's going to happen when I hit a diamond with a steel hammer, well, then this scale is going to tell us that the diamond is going to break the hammer, right? Because the diamond's harder, the diamond's tougher. But let's try it. Diamond hit by hammer. And just a quick search on Google can show all kinds of videos and examples of people doing this. Now, not every time they're able to do it, but there are times when they are able to do it. And so this is an interesting consideration, because so why is it that if the diamond is harder, that the steel is softer? How is the steel able to break the diamond then? Okay, so we look at the other material properties. Well, diamonds are more crystalline, they're harder, they're brittle. These are the material properties of a diamond, whereas steel, properties of it are like is ductile, it's plastic. And so when it comes into contact with the diamond at this high speed, that the plasticity and the ductility of the steel allows it to absorb the impact, so that it doesn't damage the hammer, and instead all of that energy goes into breaking the diamond. And so when we're considering, okay, well, what kind of cutting tools must they, or could they have had to cut these blocks, we have to consider other things, like how fast are you moving the tool. Like I can take a bullet and I can tap it on a piece of wood and it's not going to do anything to it. But I put the bullet in a gun, I can fire it through a piece of steel. And so like the acceleration of the material is an important consideration. And we can see this in our manufacturing that we do today with water jets, because water jets, they can cut through material, but they just use water. Now, yes, you do add like some sand, garnet or whatever they call it, into the water to give you little bullets to help you pick away at the material a lot easier. But you can just use the water jet without the garnets and without the sand, and you can still cut materials. You can still cut wood, you can still cut metal and other things. It just takes a longer because you don't have the sand helping you. And so what's the hardness of water? Where's water on this list? Um, the water's able to cut things. So how can we? And so you can see how this hardness doesn't really help us, because there's other things you have to consider when you're thinking about making a cutting tool, and considering whether or not something can be cut by something else. You also have the consideration of temperature. How warm is the material? So like with blacksmithing, you can't you can't cut through it's very difficult to cut through a piece of steel with another piece of steel, but you heat it up hot enough, and now you can cut through it quite easily. And so yeah, that's the thing. With hardness, it's very easy to just be dismissive and say, well, look, the materials, they didn't have the materials, but the material isn't as important as the physics behind how you're using the material. And the water jet is so interesting because, like, check this out. Where is my bearings here? Right there. Check this out. So we're here in Egypt, and so we got the pyramids down here, and then we have Aswan up here, where a lot of the blocks came from. And so what we have here is we have this big lake, right? And this lake spills over a big electrode dam that they have, that they've like built in modern times, and then flows through, and this is the sort of like the starting point of the Nile River, which eventually goes down and leads to Egypt. So today, we're using this for power and electricity. And so, like, why wouldn't the Egyptians have used this for power and electricity? This river clearly has the capability to do so, and like we have we do it now. So and like something like a mill, you can make out of wood. Like, it's not a very complicated thing. You just have to sort of build it. I mean, certainly it's complicated, but you just sort of have to do it. And then you have other things other ways you can get energy from the water, like a trompe, which is a really cool way with just pipes and flowing water that you can create compressed air. They got lots of flowing water, right? So you can make compressed air, and maybe use that compressed air again to like pressurize your water for your water jet, or maybe the mill is pressurizing it. And sand, well, they got lots of sand, right? All kinds of garnet they can use. Like how advanced would that really be? It's certainly, it's not like Star Trek advanced. It's not like space program advanced, but I mean, just seems still working. It still takes time to do and build and to make a system like that, but you don't need anything too crazy to be able to build that. To be able to build something like a mill right here, right? And like look at all these little islands and stuff here at the start of the river. You could put all kinds of different buildings and tapping into the flowing river. Oh, it's so cool to think about. Oh, where are we going here?